Oh, we're going. I'm sorry. So, yeah, sorry I went a little bit long. So, for this time period here, there is no rise, there is no run, so our velocity for that time period is 0. Again, if we wanted to look at it for a different one, for a different time interval, we can, let's do this little green one here, from here to here. So we can say our ending time interval is 80, our starting time interval is 70, so the time elapsed is 10. Our rise from 600 to 800 is 200. So for that little thing right there, we have the 0 trick, ends in 0, so we can cancel those out. 20 divided by 1 will give us 20. Well, that is our velocity every single time. Velocity is the slope of a position versus time graph. There's a few more instances where this is going to apply, and your skills in reading graphs hopefully are not forgotten by you, because we didn't do anything magical there. We didn't do anything groundbreaking. All we did was look at rise over run, that thing that you know from 6th grade, 7th grade math, 8th grade math, whenever you took it. Let's continue on. The red segment has a 0 slope because velocity of slope is position versus time graph. The yellow segment has less steep of a slope than the green because the student goes slower the last segment of the motion. The slope is 10 because velocity is the slope of a position versus time graph. Please say it. It's going to sound weird. You're maybe in a classroom. Just say it. Commit that to memory for sure. New example. Runner does the following. Runs forward at 4 meters per second for 20 seconds. Stops for 10 seconds. Jogs backwards at 2 meters per second for 30 seconds. Stops for 20 seconds. Walks forward at 1 meter per second for 20 seconds. Here we go. So going forward 80 meters, 4 meters per second for 20 seconds. Multiply those two, we get 80. Stops for 10 seconds. Jogs backwards at 2 meters per second for 30 seconds. Backwards 60 meters. Stops 20 seconds. Walks forward at 1 meter per second for 20 seconds. That means it's going forward for 20 meters. Each segment of the motion takes place with a constant velocity. So each segment is a straight line. Moving forward is a positive velocity. So these lines have positive slopes. Backward motion is represented sloping lines. Now I'm going to take a second to tell you, whenever you have a graph of any kind, here's the steps for reading a graph. Step 1, look at your axis. Or the unit, because there could be instances when you're not really sure. So looking at your axis. So we have the x-axis here. We have the t-axis here. It's not the x-axis, excuse me. It's your position is on the y-axis and your time is on the x-axis. So we know we're in physics class. So this is a position versus time graph. Okay, well, what facts do we know about this? Well, we know that says facts, kind of. Sorry. We know that the slope of a position versus time graph gives us our velocity. So, if we're on a position versus time graph and we are going down, that means we're moving backwards. The way that I like to think about this is if we are walking along a number line. Okay, so let me take this off the axis here and I'll put it on a number line. There's my 0. Here's my 0, right? This is 0 position. Our position is 0, position 0. If we move forward that means we're going to go this way. There's our forward motion. Then we stop, and then we go back towards 0. So that means we are going back towards 0. We don't do it for as long, maybe not as fast or whatever, but we can go back towards 0. And then we stop, and then we move forward for some amount of time, not quite as hard. Okay, so think about that. Whenever you are looking at a position versus time graph, then if you see a downward slope, you're moving back towards 0. Or back towards the origin, whatever the origin is. Stops are represented by flat lines with a 0 slope. Know that. The faster the object is going, the steeper the slope, whether that's positive or negative. So you can be moving back towards 0 or back towards the origin really fast, faster even than you were moving away from the origin. That just means your velocity is moving in the opposite direction. To represent the runner's motion this time using a velocity versus time graph, I'm going to do that on the next one.